Okay, I guess we should get started. Thank you all for coming on a short notice, and also thank you for Brian to agreeing to give us a seminar on a non-typical day for ASP seminar. So today's speaker is Brian Meigs from University of Miami. He's in the town for a meeting, and he was nice enough to spend a free day with us. Well, a few hours today. So he got his bachelor's degree. A little bit background on him. He's got a bachelor's degree in chemistry actually from Caltech. Then he changed his mind and decided to work on atmospheric science. And he went to University of Washington in Seattle to work with Professor Bob House there to work on the global monsoons. And then he actually then came to University of Colorado to be to work as a climate change postdoc for 2 years. And then you stick around for a while, right? At the NOAA lab down the hill. And he thought maybe I'll like a warm and a humid weather in Miami, and he came down to Miami to join the faculty there, and that's where he is right now. And today he's going to talk, tell us about visualizing the weather and climate connection.
And this warms up. There we go. Is that good? Thank you, Yu-Min. Thank you for assembling the talent of the young talent of ASP to speak to, and I see lots of other friends in the house from Unidata people in the house, and Jeff, and my NOAA homies and stuff. So, and I know of at least one person who's actually watching on the web. So, hi, Melissa, and who knows who else. Yeah, I'm here for Packer, which I hear is a 5-letter word to some of you, and agreed to do this. I'm also here on a scouting trip for a summer house to rent for my research group, who's all coming in June. So if any of you, I've been trolling Craigslist and sabbaticalhomes.com, but and nothing yet really, which is too bad because I'm here and I could write checks. So if any of you got neighbors, anybody knows any housing leads, please let me know. All right, well, I'm just going to explain to you, I guess, why I'm on about what I'm on about the last year or two. Really by way of, I enjoyed looking back. The ASP, I can be the fond old grandfatherly type here, talking about the old days with my slide rule. I started in this field really on kind of a weather adventure track, and that was these tropical field campaigns, which were even then and certainly now are sold as climate via models, via model improvement, via process studies. So that was all good fun out in the field. But then you come back, of course, to graduate school, and there's work to be done. In part, reconciling the issues around the whole thing, the casting of the whole thing. And in those days, we had one Unix machine, and it was scarce. The postdoc owned it from 9 to 5, so I got the off hours. Upside, I met my wife, who's a compatible chronotype evening worker. So that was good. In those days, we didn't have a lot of software, so I was just, writing raw C to process this airborne Doppler radar. So you can imagine a moving platform that reorients, and on top of that is a radar spinning in another coordinate system, and it's all very studly data analysis, and it gave me that disdain for easy gridded data, although now I realize you can just go farther when the data's already a little pre-chewed for you. So that arrogance is worn off, hopefully. And what passed for graphics was I had to learn to write PostScript as an ASCII file, and then you hand it to the printer, and out comes lines where you said lines, and shaded squares and stuff. The color was only on the screen, and that was all relative to the lower left corner and all this sort of stuff. So that, just in my life, we've come that far, I guess. And then as a postdoc and postdoc, I feel like I rode the wave of what I've heard called fourth generation languages. And the fast debugging just, it's an order of magnitude in productivity compared to clunky old Fortran and C, and somehow looking at the output and then going back to the code. And so by fourth generation, I understand it's interpreted, so you can take a bunch of code and just like splat it in the command line, see what it did, instead of run a script and then interpret the error messages. And instant graphification, you could say, anyway. So there's just an explosion of productivity for the people who are just my age with just my preparation ready to pounce on that, and it made me a career. But then you go off to become professor, and certainly there's a productivity slam from the research point of view. You just redefine productivity in a way. And so I just sort of retreated or stuck with my ruts and strengths IT-wise to sort of remain competitive and funded and so on. But It's not ideal. Teaching, I teach undergraduate weather analysis, kind of synoptics, and graduate data analysis, and it's kind of sad that text coding skill kind of stands between students and science. So you try to take on an undergrad researcher, it's really hard to do if all you know how to do is run your old IDL scripts and stuff. So I haven't loved that, and I'm just getting weary. The puzzle fun has worn off a little, so I'm wearying a little of these one-off programming jobs and the management of data collections. And I just wish the time I spent with my computer, at least I thought maybe, created lasting value a little more. This climate weather split has just always bothered me, this sort of scale splits of our field, which were somewhat IT driven, just you couldn't afford, monthly means were what you could afford in 1980. And the calendar is just perverse. So, for monthly, you go beyond monthly and what now, it's pentads and leap days and anyway. So I understand there are reasons for it, but it frustrates, and I go to meetings about each, and each culture can sometimes seem a bit ungrounded by the other. And sometimes I get some creeping doubts whether all this is really making any progress. I see some round and round to it all and stuff. So some days just the craft of it interests me more than the content anymore. But whatever gets you out of bed. And I think also the next IT wave is ready, mostly ready, but the bright side of that is the wear is still soft. There's still room to make an impact on how it grows to total readiness. And especially open to app access, so I just don't have to carry data collections around anymore. That's been promising for years, but now I think it's really ready. And the Unidata tools, IDV and Ramada, are also ready after some false starts over the years that a number of people bounced off it, but by now I think it's right there and ready to go. So thanks to the Unidata people and Don and Jeff, post-Unidata people, who also turned out for this. Really helped me hold my hand through a lot of this, so thanks. So maybe it's time for a new phase for me. And time, and is time money? Well, not as much as I wish it was anymore, now that I'm richer and older. But still, I wonder if visualization per se can be sort of fundable as science. It's a little bit descriptive and semi-quantitative sometimes, and the statisticians can scowl, perhaps, so that it's too subjective or self-indulgent or something. And a lot of, the validity of that critique really depends on the quality with which you're working. So then that makes the craft more interesting again, that the graphical style and color are to instantaneous fields what statistical tests are to climate assertions and so on. So there's the craft is rigor in a way, is scientific rigor in a way, and sampling again comes up. And nowadays you can with all these big archives online, you can sample any time you want rather than the case study that happened to be the field campaign that happened to be the date the airplane was available. But what's publication at the end of this? This is also a shifting landscape. Libraries are wrangling with this. Everyone's wondering, who reads anymore, first of all, and what is publication? And so is creating four-dimensional data objects and their renderings and the artifacts of those, of which animations I think of just an artifact of this larger object. You create that. Is that a publication? Well, not quite in the traditional sense. I can't recommend it to young postdocs that you try to get yourself a tenure on that basis yet or something. But so lots of questions around that, but kind of fun because those questions loom around it. And is it education? Also, how do you evaluate whether the pretty pictures you showed people really sunk in the right way to their heads? And how does that relate to the old school, lecturing on the boards, which we still do and must, I think, still has a role. So that's kind of fun. And sort of a vision, let's just call it a half-written proposal, is try to find some roles for this in the, to sell it as science again, to sell it as climate, like everything. And starting all the way from sort of causality studies, just weather study, if you like, through kind of the weather events, but in their context, to climate events, but you add texture, to climate impacts, but how do those add up across time scale? Can you make a cumulative thing that ends up with the monthly result that otherwise is a little bland to look at? So I've just been playing around. I'm just going to show you examples that sort of walk up and down this a little. It's all not as curated and done as it may never be. But let's just start at the beginning with some weather causality that I've learned a lot about from, because it's so three-dimensional, I've learned a lot about it from this IDV type visualizations of it. And this is about monsoon depressions here, which form on the east coast of India. They drift slowly westward. They create sort of half the rain of many millions of people. So these are enormously important phenomena in the world, and it's quite vertically delicate why and how they move and linger the way they do. So been studying some of these really with Bill Boos at Yale has worked it up on the statistical end, and then I sort of worked up some case studies, and we're putting them together, and it's a really useful little collaboration perhaps. So here's one case, happens to be during this year of tropical convection when there's great extra great data available. And so here's one of these East Coast cyclones, and I guess I have trim rainfall on there in white like clouds. And you can see there's actually a West Coast cyclone there too. And I had never fully appreciated, I know what 10 is, I know what 10 times 10 is, but I hadn't fully appreciated 2.5 degree to 0.25 degree, what a different world it is that you get in the structure of things. And here's another example of that. This is potential vorticity. Seen from the top, these are blobs, 3D blobs of potential vorticity. And yeah, NCEP, whoops, let's see, has a blob where the cyclone is. Yeah, there's a blob there. There must be. It induces all the flow or whatever. But wow, what another world when you add an order of magnitude. And it's of high quality. So I've just been having fun with that. Yeah, this is the IDV, which everything I'll show you is from the IDV. And yeah, which since I had to, yeah, so this is the IDV, and it's this infinitely zoomable, very adaptable, fields on and offable, kind of a interrogable space for all kinds of data analysis. And then you can create artifacts like this and use them. But so the thing about these monsoon cyclones is that they're, if you think, okay, why, you're going to ask the question, why does a cyclone move to the west? You kind of have to say, well, what is a cyclone? Well, it is its potential vorticity, maybe. And of course, there's some sources and sinks, but maybe mostly it's kind of an accumulated ball of potential vorticity that's doing what potential vorticity does, which is nothing but advect. So the potential vorticity of these things is actually centered up off the surface here. Even though the vorticity is deep and maybe even concentrated right near the surface, the potential vorticity is really in the mid-levels. And so what Boos and company have done is composite hundreds of these. And here's the potential vorticity in the color here, and you can see it's kind of two blobs with a gap between them. Maybe this is about the melting level, and maybe models are a little squirrely about it, but the center of mass of the potential vorticity is up here at about 500 in this, I guess this would be ERA interim data he's done. And on top of that, you see the contours of the zonal wind. Here's the monsoon westerlies in the lower troposphere, all this positive stuff. And then there's a little bit of mean easterlies. Well, there's mean easterlies in the upper levels, and there's mean easterlies poleward of a certain stage, and it just barely, this thing happens to sit kind of in the easterly side of the line. What a delicate thing about its vertical structure and about the vertical structure of the mean flow. It's really a delicate business, and but Boos has really, and his group have really worked through this in a nice way. Here's this joint distribution of the vortex zonal velocity, minus 2 or 3 meters per second being the most often, and the PV weighted 500 zonal wind. 2 or 3 meters per second. So the way these things linger and deliver, life-giving rain is down to this really delicate sort of stuff, which makes it interesting to imagine climate changes and stuff like this. I think it's a nice, delicate problem with real stakes on the ground. So that'll be the Boos, Hurley, and Murthy, the real paper, and then we did a little, just for a meeting, Boos, Murthy, and one of my case studies in there. So that's an example of the sort of thing that I've really enjoyed, burrowing in, interrogating data about. I'm just going to show you a few more and more animations now. I can talk less, and the screen will do more. So I'm just going to show you maybe 4 examples. One is a thing I've been studying, this climatological mean rainfall through the Caribbean in about May and June, sort of like the Mayu front or Bayou front or Chiang Mai front of East Asia. I have a student who's working that up in a nice way. I'll show you some of his animations. Extreme events, just always of interest, and you just like to know what makes them happen, and it's always some combination of set of coincidences and maybe some climate anomalies. And by the nature of sampling, it's always full of coincidences, but there might also be anyway, it'd be nice to be able to tease that apart a little or illustrate that in a nice way. I've also been looking at the whole hurricane seasons. There's sort of it's been, there's a great coherence to hurricane seasons. 2005, just, breaking all the records. 2013, hardly anything. And the storytelling around that is unconvincing. And even after the fact, when all the data's in the can, nobody knows the story of that. So I've just been making big, beautiful pictures and trying to, see if I can say something. And my take on it is it's all about this dry injections of dry air down the east side of the Atlantic. Not from the Sahara per se, but just, from poleward where theta surfaces slope down. But we'll see. And I have a rather ho-hum thing I might skip about just putting some, infrared texture on monthly anomalies to see what El Niño looks like on the ground on a particular day. All right, so here's this Caribbean early rainfall season case that Teddy, my student, is studying. In April, there's just hardly any rain in the Caribbean. Florida, lovely time, come on down. It's wonderful. Angie knows. April's the last of the great months. May kind of turns around in May, gets soggy and hot. And then July, actually, there's this gap in the rainfall, kind of, So that mid-May to mid-June period, which monthly means don't do it justice, so we've been sort of redefining it as mid-May to mid-June. There's what it looks like. Yeah, the islands are involved, but it's more than that. It's really a whole, plume of rainfall on a certain scale. And if you go to particular years, you can see that feature there, sometimes more upright, sometimes more splayed out. And you get the feeling this is somehow the mid-latitude subtropical kind of interaction. So let me just plant a question in your mind. Are we looking at upper level dynamics like these digging troughs in the 300 millibar? There's just lifting motion ahead of these troughs that come through. There's the vorticity and there's the heights. This is all rather crude, 2.5 degree old inset, but works well enough. And then at low levels, I have 850 winds here, trade winds coming up. Where do they come up exactly? They bring the moisture up, and how far and where and how much. So keep your eye on that. And I guess I'm just going to loop through several times, once with just the upper levels, once with just the precipitable water and low levels, and then with the rainfall, and you can see what the rainfall is connected to, and so on. So there's the signal we're going to explain. Belt of rainfall through here. And yeah, these troughs do swing through, and you can imagine probably every one of those is doing some weather making. There are also these upper level things coming from east to west down in the tropics. Precipitable water, though, blue and the blue arrows, very much it's about these tongues of tropical moisture getting drawn northward. And so yeah, there's vorticity dynamics, but there's also moisture supply, and these are sort of the two great things. So here's the white now is rainfall, and you can see it accumulating in the background. And if you ask me, it's all about those blue tongues quite a bit. The rainfall sort of follows the blue tongues. And so when you end up looking at the monthly rainfall, it's about where the blue tongues spent their time during that month. Maybe more than it is about upper level, quasi-geostrophic liftings. Although those things are not uncorrelated or unrelated. So that was one year. Here's a different year, just different color scale. And again, the white on here is daily rainfall, and the accumulating in the background is the monthly, growing toward the monthly mean. And the kind of lurid dark blues are the moisture. And again, I get the feeling that it's where there's enough moisture, convection happens. Yes, sometimes forced, sometimes not forced. It's kind of about the where the blue air spends its time, to me. This is really how I've come to think of things, and I've wondered if we can make kind of a Lagrangian view of the general circulation, and climate diagnosis might be a useful tool here. I mean, you can just look at the tracer itself, precipitable water, and I'm doing that, and quite into precipitable water, but we could also make somehow just sample the wind fields about how far they get rather than what the velocity is. See what I mean? So all right, that's one area I've been working in. Another is just plain extreme limits. This is actually where this all started for me. Between teaching and this was like a monsoon heavy rain. It's a WMO panel that I'm on. It's sort of a volunteer thing, and it's a little bit capacity building or whatever. It's to help the world. And so I just made this web page you could go to about the heaviest rain in 10 years at any given point, as seen in this trim 3-hourly quarter-degree rainfall. And you can, if you're on this web page, you could go and click on any point, and it'll tell you about, what date was that, what time was that, and then you want to say, well, what's up with that? So if we went over here to say Vietnam, and I picked a point, it would be something and something, and it rained 600 millimeters, and there's a date, and there's a time, and all I knew how to do before I discovered all this IDV and OpenDAP stuff was. It looks so dated now, 2 years ago. Wow, there's a website of all the full disk satellite pictures ever. So I could get full disk satellite pictures, but didn't satisfy. So nowadays, here's what I can do for Vietnam. This is a case in November of 1999 in which it rained really a lot right here in central Vietnam. Hue City, I guess that's called. And so what's going on with that? It's partly just a seasonal matter that what they call the winter monsoon, kind of enhanced trade winds coming in here. It's really the Siberian high, great big continental scale Siberian high. So the easterlies on the south flank of that are roaring in here. And I'm sure there's topographic rainfall on all these east-facing heights. But it's interesting to notice in this case that it's also kind of what you might call a non-traditional tropical cyclone underneath all that. Sort of a monsoon cyclone. Again, like these Indian ones, it's not a tropical cyclone in the sense of, becoming a hurricane or anything. It's just a cyclonic flow. It sort of sits there and amplifies this onrushing flow here. And it isn't like it's not like the core is full of convection. It's kind of just, I just want to do like a PV budget and see what the heck's going. Why does that thing sit there and kind of keep spinning and maybe spin up a little, and then toward the end it migrates north. But just the upshot of all that is 6 meters of rain in Hue City. A lady wrote me about how much she hates all storms and wants to become a meteorologist because of being waist deep in muck during this thing. And then who can forget the Boulder floods? Of just last fall. And again, you probably all saw that decomposed to death, but it's kind of here's a Rex block. They call it a cyclone under an anticyclone, kind of a cutoff cyclone under an anticyclone that cuts off, and the two of them mutually self-advect this way as the westerlies would carry them that way. Point is, they sit there long enough to do this long fetch kind of trajectories that bring the moisture, I think. And then, of course, local effects that I'm not looking at. But I think it's kind of all about getting a pattern that is persistent enough for long fetch trajectories to happen. And it's not something we're really super well set up to measure with our traditional kind of Eulerian statistics of the time series at each point. It's what visualization tells you all about, it's what weather's all about, and it's what climate diagnostics just doesn't have nutshelled as well as I wish it did. The tracer itself is probably the best thing we have. Precipitable water. So, all right, and again in the same sort of theme here, long trajectories, precipitable water, climate anomalies. This just toggles back and forth between the 2005 hurricane season and the 2013 hurricane season, a month segment of it or something. And 2005, record-breaking, tons of storms, big mess for the East Coast. 2013, nothing, easy. And the difference, what is the difference? It's kind of in this, precipitable water through here, which is kind of in how long and straight the time mean flow is. Actually, that's maybe decently captured by the time mean flow and the time mean moisture. But it sort of begs the question, I don't know, you could say it's sort of anomalies in this area of some sort, but it's really about the pattern, I think. I mean, the explanation is at pattern level, not at Eulerian time series anomaly level, I think, but I don't know. So I just made, 2005 on top, 2008, 13 at the bottom, and here's the day, here's the day Katrina was hitting Miami on its way to New Orleans. And here's the same calendar day during 2013. And look at all that just dry brown air. I mean, it's a protective wall of some sort, seems like. I don't know. Let me jump out of this. Just show you that thing as a movie, if it's any fun. So yeah, there's good old Katrina. And more and more storms in the top, not much in the bottom. These big, dry, wall-to-wall dry slots that just sort of prevent the deep, dark blue air, which gets full of convection when it hangs around long enough from accumulating. I don't know, this bears a lot of looking at, more than I'm going to show you. But we also have in Miami a lot of local SST maximalists as far as explaining things like hurricanes. So I made just a same loop. This is just the red and blue in the background now is SST anomalies, daily SST anomalies. And you just never know what to look for in SST. I never find it very compelling in a very local way. And yet we know now that whole hurricane seasons are enormously predictable given global SST patterns. And I think that must come through, the large-scale flow and the, large-scale eddies and so on. Not the local, whether it's warm at this point or not, like you'd explain. This hurricane happened because it's warm at that point. So I don't know how to do that. It'd actually be interesting to maybe have, anyway, I don't know how to take this apart, but that's what I've been doing, some of that. Too big to put in a PowerPoint, 300 megabytes. Continuing in probably still this theme, but jumping back to the other half of the world. There's a very common, and back to selling all this as climate model improvement, which remains my stock in trade. This is from a particular model, the unified model of the Met Office, but it's common to many models, and that is it rains too much down here on the western equatorial Indian Ocean, and it rains way too little over India. I don't know, you could say maybe they're missing those cyclones, but these anomalies are linked. Bolasina and Yi, I think, at GFDL played a little game with turning on and off heat sources here, and in the background flow, this thing, has an effect over here that this anomaly, rains too much here, is a cause of rains too little there, and it kind of spoils all kinds of monsoon forecasting and climate change believability and stuff. That this western equatorial Indian Ocean wet bias and its downstream kind of impact make a bias common to so many models. So what do all the models have in common that's bad? I think it's the moisture sensitivity of their convection schemes, inadequate moisture sensitivity, but let's see if we can see that. Yeah, so let's just, so here is, this is my other, short of making my own animations, this is my favorite product nowadays. It's called Mimic. EPW comes from Wisconsin. It's a way they have of stitching together all the microwave satellite measurements of precipitable water, which is a well-measured quantity. And they've stitched it together by advecting pixels around and then overpainting them as the satellites come in. And so it has these little pops and sparkles like listen to old phonograph records, but it has an enormous continuity through time that has really turned my head about what makes the tropics work. And they have a color scale that's also pretty well calibrated with forecasters and so on, that around 50 is real steep. And there's a published research of this too, that here's precipitable water 20, 30, 40, 50, 60, and here's precipitation rate on average or something. And man, after about 50, it really shoots up. So in a way, this is an example of where this curve from statistical research really belongs as a color scale. So I really want to turn that curve into a color scale so that we're really looking at the right color scale. But it's pretty well calibrated that at 50 it starts getting orange, and that's right. And what's going on out here in the western Indian Ocean is there's some real long-lived islands of high to modest to high precipitable water that hang around here and rain and rain and rain. And it isn't that the convection doesn't remove them, because the convective heating causes moisture convergence that sort of sustains it. There's just it's almost given me I think there's a quasi-equilibrium of moisture content that needs to be sussed out. But anyway, I think it's something about models that are a little too moisture insensitive. Maybe they're raining here and here and here. Maybe they're raining at 40 already. And then, yeah, there's warm water. There's no reason not to rain here from a parcel point of view, the sort of things convection schemes have. But where it's really raining is only in the precipitable water above 50. So that's my working hypothesis about what's wrong with so many of these models. So here's back to my blue color scheme, and I've put the infrared and trim on top now, and you can really see when these little tongues of moisture come out, they are full of high clouds and deep convection, and nothing else is. Let's say this one, for example. Here it comes, hangs around, rains and rains and rains. It's raining many, many millimeters per day, and yet the millimeters don't go down across many, many days. So it's some kind of moisture convection self-sustaining feedback. And most of the time, it's not raining there because those tongues aren't there. But your average climate model might be happy to be pouring there all the time. That's my thought. All right, so maybe the last little, the last little thing I'm going to show you, and this is a little lackadaisical because I don't quite love El Nino, but I just want to paint out I've just been trying to paint out some of the things that one could do. So what we know about El Nino is that during a warm event, the Pacific jet stream in the subtropics stays strong and low latitude, cuts under the southern tier of the United States and gives a wet bias. And I wonder if we could see that. So what I've done here is make one, actually playing with time a little more, like I haven't. To date, everything else has been, all those animations had constant time steps. But you can kind of do this little nesting game in time too. So here's monthly SST anomalies for a while, then daily OLR and zonal wind to see that jet stream, and then 3 hourly, for a case when it rained a ton in California, and then back to the daily, and then back to the monthly. And this is all for a whole, this is for 82, 83 winter. So first you see the 82, 83 SST anomalies develop month to month till January, till whatever month this was. January to March, I don't know. Then in the heart of the winter, I've sort of gone to this daily thing, and then so I don't know, let's just play it. So there's the SSTs monthly. Now what does that get you? You're in the middle of winter with those warm SSTs. There's a lot of OLR, 2.5 degree. It sure does satisfy less and less. 2.5 degrees is starting to really feel clunky to me, but sure is fast. Oh, and then, then in the middle of winter, all right, now looky there. Now there's our jet stream racing through there, and there's these cyclones. Then back to the blurry view and on out. So it's the sort of thing you can do is add texture, and if only for sort of outreach or something like that. Texture's worth its weight sometimes. All right, so let me just say a few things about how I'm doing all this. And this is this software, the integrated data viewer from Unidata. And the first thing I tell people who get excited and want to pick this up is, take a breath, because you're walking into this. It's not quite this. And you could find a screwdriver there, and probably there's even crescent wrenches in a place like that, but they aren't right on top, and it's just not quite the right way to approach it in there. And you should be cautioned, there are a few areas that are a little bit under construction still. And so, although the training starts this way, I think starting from raw materials, raw data, open a data file and begin to make your first display is not to the strength of the tool. And rather, I'd say it's nice to start from complex bundle and adjust it. So, you know, you open the engine hood and you adjust the timing rather than building a car from sheet metal. Although it'd be lovely to learn to build a car from sheet metal. So by way of trying to make this easier and more approachable, and thanks to Don, I've learned to make a thing called a plugin, in which you can find by Googling, you know, those words or my name or whatever. You can watch some screencasts about first why you want it, then how to get it, and then where it goes from there. And plugin is just a couple of files, and you sneak them into this little special directory, and you get all kinds of favorite things of mine. So a lot of work I've done, you know, is available to anyone by that. And so one of these is a favorites bar here, where I have this. Still don't love my curation. Doug's helping me think about how to folderize all this, whether to preconceive all the folders I'll fill, or kind of do what I'm doing and then catalog it later. It's really hard. These kinds of choices are really hard, but attaching, you know, the new data sets are certainly a gold mine. Lots of work trolling the internet for, you know, reliable, good data sets that really sit on servers that are really there, that are really aggregated across time. So you can just plug in and set your date, and you will get your data. So I've done a lot of trolling of that. This is my favorite. This is what supplanted that website of full disk images from all of time. This is global infrared brightness, 1/10 of a degree for 30 years as one data file that you just query by longitude, latitude, and time, and sends it back. So that's sitting at NCDC. So people do enormous work to sort of package that up in a nice way so that it's pretty responsive. And there's more and more of these things where people have done that legwork upstream. And wow, you want a satellite picture from anywhere, anytime. You don't just want an image. Why not have that as data and layer it on top of all your other data sets? I'm also a big fan of Mera, which has just all their fields, not just the state and layer averages, states and stuff, but budgets and layer average budgets, and clouds and land surface stuff, and momentum budgets and heat budgets, and on and on and on, and it's all there. And yeah, you can just take apart any kind of thing that happened on Earth that's in Mera real well, and if you want, you can just attach them all here, for example. So that's one thing I've added. I've also just a few little conveniences that I like. I've sort of exposed a few more formulas in the GUI here that before this you had to know that you had to burrow in and type their names. You had to know their names. Stuff like that. I just have some suggestions in the display settings, you know, thick blue, 5 millibar contours, you know, instead of contours, now set them blue, now make them thick. Stuff like that. So this is what I'm trying to build. And so far, still, you know, a personal effort, and with my personal name on it. I'd love to have enough people involved that I would rename it as the Miami ID, you know, something not just me, but curation's important, and without a name, curation doesn't happen. And so for the moment, this is where I'm at. So all right, visualization can make the weather-climate connection clearer. It feels like knowledge to me, at least with all my mental preparation to be ready to interrogate these things, but it certainly isn't journal publications, and I don't know where that all leads. Caribbean early rains. I showed you that I think precipitable water is more and more has turned my head as the go-to variable in the tropics, and that its history is really a Lagrangian flow statistic with a 5 or 7 day kind of time lag to it. That's so different than the instantaneous velocity field view. So anyway, that's a theme that came up and up. Extremes are often about persistence, not strength. And so again, I think that's through these trajectory length kinds of diagnostics I'm trying to build up data sets of for better visualization. Hurricane seasons, again, kind of dry injections. Again, it's precipitable water to me, but I'm happy to entertain other ideas and help sort that out. Monsoon bias in climate models in India. Another great natural laboratory, I think, for this phenomenon. And things are prettier with texture. So I think all this stuff is ready at last. The IT side of it is ready. But it needs a kind of user, caring user curation kind of work that's actually fairly laborious. I'm passionate about it and enjoying it, but I can't keep that up forever. And so I want to know what it's called and how to make it a thing so that it isn't just me anymore. So anyway, thank you for your attention.
So questions for Brian?
Yeah, so if you think of something like NCL, where it started off, as far as I can tell, as visualization, and then got a lot more data processing attached to it. What do you envision for this type of interface, and as far as when you want to do some processing? What do you fall back on? Can it interface with other?
I'm sure Don and Jeff here know that history better than I do, but I bet it did start that way. As first you make the pictures, but then somebody realized, well, geez, all these formulas. Somebody wants Q vectors. What do you got to do? Go make them in Fortran, and now this is just to show them?
Right.
No, you build in the Q vectors. So here's your frontogenesis, and Q vectors are just off the page, and all these things are in there. And it's easy to add more, and it runs Jython. So anything you can run, if you can write a Python script to do a thing, you can have it happen in real time. Of course, that's between you and you getting your picture. So you're not going to sit there and watch the paint dry. But on the other hand, it's a way to kind of, and this, for someone like students, this is a way to, where you're sort of using the logic, the algorithmic logic that you use in programming, but you use it in a GUI kind of way, and it just feels like you're building things. You don't have to turn on that, what's the name of that text command, part of your brain. And for me, that gets in the way. So I think more and more you can calculate things like this. And again, every time you save it, you're saving the whole code. It's not a code you'd ever read. Yeah. It's 200 kilobytes of inscrutable, uneditable XML. But in a way, there's a high repeatability to it, in principle. You could forensically take that apart. I still wish that it was a little more take-apartable, more modularized, that you could take out a thing you've done once and do it again quicker. But I'm still working with them on all that. But more and more, I hardly ever fire up MATLAB and IDL and stuff. Because anything I can do this way, I'm trying to just as my own skill. And I think, man, I haven't found the limits of all the good things it can do for you. It's certainly a great intake engine, for one thing, because you can just regrid any field, any other field, and then you can sort of write out a netcdf file. You can toss out netcdf files from it. So you first run it under your eyeballs, then you toss it out, and you know it's the right time levels, and you know everything's aligned. Now you can put your statistical munching onto that and just be confident that you didn't mistype the number of seconds since the birth of Jesus or whatever the dates are in, that sort of stuff.
Hey, is there any, easiest question is there anything it doesn't do that you feel like it should do soon, or you feel like that it's the kind of, that bit of work that we do traditionally is still in place and it's not quite there yet?
Yeah, I have a development list. They have a development list. There's a development team, and what did they say? There's 1,000 things that need doing. 100 of those are really important, and there's time for about 10. But I've gotten on all their guidance committees and things, so I can kind of help inject things, move things up that long list. There's plenty of things it doesn't do, certainly, and I haven't learned all the things it already can do. It's also very scriptable, so you can go through this GUI stuff, make your thing, and then write that out as a script, and then you can call that script. And in principle, you could put more and more arguments to that script, like put new dates, new times, new latitudes, new longitudes, move the box. You can't so far. You still have to kind of go in here and reset the calendar widget like you're booking another flight and stuff like that. But more and more, I wish that the scriptability, led really far really quickly, and it doesn't quite yet. But all these things are doable. It's just takes the Java programming, and all that goes through. And there's a maturity to it that they don't just toss in features. They sort of make sure everything's backward compatible. There's an overall. It's nice that it's curated. The thing itself is curated in that way, and so So I like that about it, but it can be a little slow moving. If you're waiting for the next feature, it can be a little slow moving. You go do your thing somewhere else until it comes up.
I'll ask another question since I've got the microphone. So what about model data? Like, for example, have you any plans, or can it currently ingest like CMIP data? I mean, a lot of people are analyzing CMIP5 and
Yeah,
data.
any format it doesn't currently read, they will make it read. It reads every format, GRIB and anything that's, what do they call it, CDM, Common Data Model. So anything that's been written out by an official script, that's a little bit of a moving target too, but that stuff gets fixed pretty quick. So it's just a matter of having an archive that's interrogable by it, and more and more that's good for that. So and I have it running on Geyser if you want, which actually took a little. It's really meant as a single user computer personal software, and I had to go in and change the memory, the amount of memory it grabs and stuff like that. So if any of you want to run this on Geyser or Yellowstone, write to me. It's installed, but not, you wouldn't find it unless you know, and you have to start it. You have to run the VNC or something. I forget.
I have a question about speed, efficiency, and reproducibility, all wrapped up in one. So when you pull down this list and you go down to Mera 3D 3-hour clouds, and you plot the clouds for some day in 1996, you're pulling that from a server, right?
Yeah.
And you have to download it to your local machine. But then if you want to do a difference between 1996 and 2004, you have to pull down more data, right? So every calculation you do, you have to download the data.
You don't download it and give it a name and put it on your disk
Right,
somewhere.
but it has to retrieve it. And so then tomorrow when I come in and forgot what I did yesterday, do I have to do it again? Does this slow down the workflow?
Yeah, it depends on the nature of your workflow and whether you like watching paint dry or not. At some point, you're never gonna watch the paint dry. So it's all about the ultimate speed of your workflow. If you're like me, the ultimate speed of your workflow is your error rate. It's debugging. Debugging is productivity, and so for me, the ability to kind of just very visually choose times from calendars and stuff has a lower error rate than the old coding approach to things. But then you click go, and then you go have a coffee or read your email for half an hour or something. And maybe it only took 10 minutes, not half an hour, but so there's always that stage. And so I don't really care about performance right in that while it's doing its thing.
Okay.
It's all about the time it takes to make it do the right thing. And
So you've got IDV kind of sitting in the background, and then you come back and look at the result.
yeah, exactly. It's multi-threaded, doing all its stuff at once. You can't look in on all the things it's doing. There's no progress bar that you trust about it or anything. You nervously push the go button, and you take some care before you push the go button. You push the go button, and then you go do something else, and then you come back and wow, man, there's gathered from 11 servers all over the world are all the reanalyses depictions of my monsoon cyclone. And snazzy.
Sorry, I'll ask another question. On like the kind of bug reporting, if something goes wrong, I mean, is it kind of
Yeah, it goes straight to these guys. It goes straight to the lead developer.
Okay.
Yeah. It's a tremendous service that Unidata has. The developers are the support team, and they're responsive and good. And it's because it's not as popular as it should be that they still get to be responsive, and it goes straight to the developers. But we're lucky right now that way.
This actually is about the science that you were showing, not about the IDVs.
Great. That's what it's supposed to be about in the end. Yeah.
And it's not a question, just an observation. Your Caribbean early rainfall.
Yeah, Jamaica.
Yeah. All the famous floods that Jamaica has had, those that are 10-day floods, 13-day floods, have actually happened in May. So
Yeah.
I want to follow up with you on some of that discussion because the usual discussion was about the fact that it's the overhead sun and that's why it happens in May, and not very much has been done looking at it from this point of view as the idea of this sort of monsoon related front or this sort of Mayu type of thing, because they're not used to thinking of things in that way.
Yeah. Yeah, that's right. These early rains are, yeah, some huge disasters on Hispaniola, Haiti, and so on. And actually, I went to Cuba, a meeting in Cuba several years ago, and they sort of have two problems. One is, of course, tropical cyclones, and that's their number one. But always the second biggest flood in any town was something in March or April, or, well, I mean more in like May. And it's often, you know, south coast kind of, it's this sort of stuff, you know, high precipitable water slamming against the south coast as a trough, just kind of gently, you know, destabilizes or something. But it isn't about, you know, a front comes through.
No.
It's so misleading to call it a front. It's more, you know, there's gentle uplift and more to the point, sort of persistent moisture delivery.
Yeah, it's actually the southwest part of Jamaica, the parish that I'm from.
Yeah, right. It gets those spring rains. Yeah. So it is, yeah, it's a whole phenomenon. It's well known to those who know it well, and probably has names in all sorts of different languages on those islands. But unlike East Asia, which is, you know, yeah, it's just more politically scattered region, and so it doesn't really have a name the way the Mayu Bayou has a name and a literature around it.
Any other questions for Brian? Then let's thank the speaker again.
Thanks.